Prediction of biomethane production of cheese whey using artificial neural networks. ID of the paper 8025. The problem. Cheese whey is the effluent produced during cheese manufacturing. The global production of this cheese whey was around 186 million tons per year in 2008. And only half of this was industrialized, while the remaining 50% was discharged with a very negative impact to the environment. So a solution could be to leverage this cheese whey for the production of biomethane by means of the process called anaerobic digestion. However, many parameters affect this process of anaerobic digestion. For instance, the substrate to inoculum ratio, among others. So it is very interesting to have some kind of model of this process to predict the behavior and then to be able to optimize the process. Then the purpose of this work is to obtain a model of this anaerobic digestion of cheese whey with an artificial neural network from collected data that we could obtain in our labs. This also allows in parallel the evaluation of biomethane production of cheese whey and the effects of the inoculum amount to optimize biomethane production. The research methodology consisted on obtaining the cheese whey from a local enterprise, La Casiana, as the substrate and sewage sludges as inoculum in different proportions that we called A, B, and C, as we can see here. They were put in batch bioreactors for the anaerobic digestion process, and then the biomethane production was measured with a portable Langdem GA2000 instrument. We also characterized the mix A, B, and C with some other measurements explained in the article, for instance, volatile solids and the pH. In total, there were 10 input measurements for this characterization and one output measurement, which was the biomethane production. And with this, we confirm different data sets. With these data sets, we tested different layouts for a multi-layer perceptron, and the best results in terms of the root mean square error and statistical analysis that is explained in the paper was a multi-layer perceptron with 2 hidden layers, 10 input neurons, 15 neurons in the first layer, 10 neurons in the second layer, and 1 output neuron with the production of biomethane that it was the objective of prediction. The results of this model were compared with the classical modeling for methane generation. These classical models are also expressed by these equations, are the first order model and the Gompertz model. As we can see, regarding the 2 figures of merit selected for comparison, which were the correlation coefficient R square and the root mean square error, the proposed artificial neural networks had a better prediction, and hence it is a better model, which is the conclusion of this work.